Okay, I got the aperiodic wobble flop mode going on with the diode. I had it on full oscillation for quite a little while, so it did drop the input battery down to 12.33, but that's okay because I'm just playing around here. But anyway, this is up to 13.6, well, just jumped to 13.64 right now, and this is the charging going on. So you can see the multi-oscillation legs with each pulse, and it varies. It's flopping in and out of oscillation. You can see those group of oscillations there. Now you can see that the amplitude of the oscillation is way up this much instead of this much. Now to get a higher amplitude oscillation, you need just a little bit more on time than bare minimum. But anyway, you can play around with it and try these different options. So anyway, bottom is power battery. Top is battery getting charged. Battery getting charged is at 13.66, 13.67. This is to 12.32. Anyway, let's see what happens now. So there's some good aperiodic, some good wobble going on. You can see some are a little bit more steady than others. So it is aperiodic right now in the wobbling. Let's see. 12.32, 13.70. Okay, now I got some serious long burst, short burst alternating, and this is on 1 second interval. And you can see that now it's on 40 millisecond interval. Long burst of oscillations with a long burst of normal pulsing in between. Two-second interval. And you can see that this COP shows the same thing. Nothing to do with refresh rate or aliasing. This is what's happening. And one thing that you might want to try as far as these circuits is put your hand around a coil, MOSFET, different parts of the circuit, the pot meters, and what you're going to see is a little bit of variation in what's happening. So I'm going to put my hand here on the inductive resistor, and what I'm doing is I'm acting as a capacitor, and I'm pulling the free radiant potential around the circuit into my body, absorbing it, which means that the way that the circuit is able to store its own capacitance is taking a lot longer to charge up, thereby slowing down the pulses. And it'll take a little while for it to get back into oscillation, but oh, there it is right there. Okay, so if I let go, now it's going to start rhythmically beating on its own right there. About 55 beats a minute. Same thing with putting my finger on the MOSFET. Slow it down a little bit. Taking a little bit longer to do its thing. See, I'm on MOSFET because I'm soaking up some of the capacitance necessary for it to charge up and produce its own supply of radiant potential to be able to deliver that extra capacity to the switch for its oscillating effect. And if I let go, right there, it'll just come back in on its regular, a little bit faster. And it's up to the experimenter to just see what interval, how much of the total time do you want in oscillation and how much do you want in regular pulsing. But just make sure it's not 100% pulsing and it's not 100% oscillation. Regular pulsing you want broken by oscillation bursts, or oscillation bursts you want broken by regular pulsing. And it can be either periodic or aperiodic.